Let's start with pre-example for A. Let's distribute. What's x times x? X squared. Outer minus 5x. Inner plus 5x. If I had stacked those vertically, I would have seen right away how nicely they would cancel out. 5 and negative 5 multiplies to give us negative 25. We're left with x squared minus 25. My outer and inner terms canceled out. My two factors looked very similar. The only difference was that one was minus and the other was plus. See what I did there? There's a special word we use to describe terms that are the same expression, only differing by the sign between them, plus and minus. We call these conjugates of one another. This is a very, very important word. And I want you to really memorize what this word is describing. A plus B, A minus B, conjugates. And this right here is called the difference of two squares. Sometimes I write dots for short. Let's look at that example. 3x times 3x, 9x squared. Outer is minus 21x, but I'm really wasting my time writing it. Inner is positive 21x. Again, I just wasted my time writing it, multiplying. What if they were really hard? Silly me. Positive 7 and negative 7 is minus 49. So really, 9x squared minus 49. And we have another difference of two squares. We say squares not because they're boxy, but because they are something times themselves. We can put on our square root glasses. What is being squared to create these terms? That's going to help us factor. Let's look at example 10 using a method similar to the one we used for the cubing examples. What's being squared to make 64x squared? 8x. And what's being squared to make 225? 15. I really can't stress enough how important it is to memorize that list of math facts I shared with you guys at the very beginning of this 5-part series. Next, similar to the little cubes, we're going to take those 2's and toss them to the side. Our first parenthesis is just 8x minus 15, and the other one is just going to be 8x plus 15. I haven't really come up with a clever story for this. That's all I got so far. One more. What's being squared to make each of these terms? 196 you should recognize as a perfect square. It's 14 times 14. X to the fourth. What times itself is x to the 4? X to the second. 169 is also on that list of math facts. That's 13 times 13. What times itself is y to the 6th? Y to the 3rd. We're going to set up our two parentheses. Take away those little squares on the outside. Write down what's left, 14x squared minus 13y to the 3rd. And then just duplicate it, but make it a plus sign. Maybe this is like the evil twin and this is the good twin. I don't know. Oops, gotta be plus. So remember, when one's minus and plus and they have everything else in common, we call them conjugates of one another. Here we have some examples that look like the examples in the second set, where we did factoring by grouping. But if I had to guess, the difference of squares or sum of cubes or difference of cubes are going to come up in these examples. Greatest common factor right here is 4x squared. And out of these two terms, is that correct? Nope, it's -9. Don't forget the sign. Bring that 4x squared out front, and that -9. Pretzel, pretzel, what's left inside? If we reduce using our pretzel, we're going to have x plus 1, x plus 1. If it matches, we're doing it. Bring x plus 1 out front. It's my super greatest common factor. So we brought this out front. There it is. What's left inside? 4x squared minus 9. Now, why wasn't this example in the earlier set? Can I take this problem further? Here we have a difference of 2 squares. That's really 2x squared, and that's really 3 squared. I'll be able to factor that with the use of conjugates. The x plus 1 just comes down for the ride, and we take away those little squares, 2x minus 3, and 2x plus 3. What's the word we just said describes these two terms right here? They are conjugates of each other. So our final answer, x plus 1, 2x minus 3, x plus 3. Anytime something's in parentheses, you could say times the quantity of to describe that it's all grouped together in one set of parentheses. Greatest common factor, 8x to the third. Greatest common factor looks like a whole lot of nothing. That means positive 1. Bring your greatest common factor out front and leave a nice set of blank parentheses. And using that pretzel in your mind or a pretzel on your paper, I do suggest a highlighter so that you could kind of still see through it. What is left? Reduce this, x squared minus 1. Same, x squared minus 1. Don't assume. Always make sure. You know what happens when you assume? You make a something out of someone and someone. Now we have our super greatest common factor. X squared minus 1 comes out front. What's left inside? 8x to the third plus 1. Can I take this problem further? You betcha. This right here is the difference of 2 squares. This right here is the sum of 2 cubes. What does that mean we got to look at? We got to put on our glasses. What's being squared? What's being squared to make a 1? What's being cubed to make 8x cubed? What's being cubed to make 1? Here, it's a little harder to look at. It's getting a little messy, okay? Here, it's the difference of 2 squares. So we're going to have 2 parentheses. Drop the squares, x minus 1, and the other is just x plus 1. That one is the sum of 2 cubes. Here we'll have one smaller parenthesis and one bigger. Drop the cubes, put them in your pocket. 2x plus 1. Then 2x times 2x, 4x squared. 2x times 1 is 2x. 1 times 1 is 1. Then use that soap and wash off all that glitter. Same, opposite, always plus. And here we have another beautiful factored answer. Hope you're getting the hang of it. Try this example on your own and see if you can get the following answer. Press pause if you don't want to see. Here's one answer. However, this is not the best possible answer. Think about it some more. Press pause and come back when you're ready for the real, fully factored answer. This right here is the real, fully factored answer. Also, just to clarify, it doesn't matter if I put x minus 2 or x plus 2 first or second. Commutative property, they're interchangeable. The work for this one will be in an extended video. These are meant to challenge you just a bit to see what you can do on your own. I know you'd want to see the work, but try to get this factored into the pink solution right here on your own. Now, press pause and try to work out 15 and see if you can get that example fully factored. Press play when you're ready to see the answer. Did you get this answer right down over here? If not, challenge yourself and go back and see if you could figure out how I got this answer over here. I'm sure you could figure it out, especially now that you see the answer, and give it a little bit of thought. You can do it. The work for this example will be in an extended video, but I'd rather see that you pushed yourself to figure it out on your own. Here's your last challenge. This might be easier for you because I feel like people tend to like this style best. Did you get the answer that I got down over here? Maybe yours is really close to it. Look more carefully. And maybe I just did something to simplify or rewrite mine just a little extra. Don't give up on yourself. I'm sure you're really close if it's not exactly like mine. Look into it. You got it. I hope you found this section of the 5-part factoring series helpful. If you feel like you've mastered this type of factoring, be sure to give the video a thumbs up for your records. However, if you have not mastered this type of factoring yet, give this video a thumbs down so you remember that this is a video that probably deserves more of your attention. I won't be offended, I promise. It's to help you remember what you need to practice and maybe to take out a little bit of steam on the lesson video that maybe frustrated you a little bit, but eventually you'll be able to come back and give it a thumbs up and show the video who's boss. Have a great day.